This is Geometry B, Unit 4, Right Triangles and Trigonometry. Lesson 4, Angles of Elevation and Depression. Last lesson we learned to use sine, cosine, and tangent to solve right triangles. Now we're going to look at some specific applications of that. We're going to be dealing with right triangles in the real world. But we're going to deal with it in the context of something called an angle of elevation and an angle of depression. So I want to draw your attention to a situation. We have somebody standing on the ground, right? So here's going to be the ground. And somebody is standing on the ground. So I'm going to draw a little stick figure here. Okay, somebody's standing on the ground. Now there's a helicopter up over here. Okay, so a little helicopter, we got the rotor blades and so forth. Okay, and so we have a pilot up here in the airplane, in the helicopter, and he's looking down at the person on the ground. Now, point of view is where we get angle of elevation and depression. From the helicopter pilot's point of view, the person on the ground is beneath him, below him. And so he is looking down at an angle of depression. So that's known as an angle of depression. And we measure the angle of depression off of the horizontal. Okay? So off of the horizontal, we measure the angle of depression. So this is an angle of depression. Meanwhile, the observer on the ground is looking up at the helicopter. Okay? He's looking up at the helicopter, and so he experiences the same situation differently. His point of view says that's an angle of elevation. Now, the cool thing about this is that when we compare with the horizontal to the helicopter and the horizontal to the person on the ground, they are parallel. They're the same horizontal. And so when we look at this situation, what we're actually dealing with are alternate interior angles. And we know when lines are parallel and they're crossed by a transversal that alternate interior angles are congruent. So if you're given a scenario in which you have an angle of depression and an angle of elevation, they are congruent. They're the same measure. Okay? So let's translate this into a situation here for this particular scenario. Let's give it some numbers. In other words, I'm going to tell you that the height of the helicopter is 100 feet. So he's 100 feet in the air. Okay, and by the way, we're not really accounting for the height of the person. So we're going to simplify the problem a little bit. 100 feet in the air, and 100 feet in the air is perpendicular. We call that normal or orthogonal perpendicular. So it forms a 90-degree angle with the horizontal. So 100 feet straight up. And the distance of the person to a point directly under the helicopter is 150 feet. Okay? And so the question I might ask is, how far is the helicopter from the person, from the observer? That's a very valid question to answer, to ask as a mathematician. And so I can use trigonometry to answer that question. Now, in this particular case, I happen to know two sides of a right triangle and need to know the third. So for that, we can jump back to what we remember about the Pythagorean Theorem. Pythagorean Theorem. In that case, I need to know the third side. So I'm going to use a squared plus b squared equals c squared, remembering that c must be the diagonal, the hypotenuse. So a squared is 150 squared, b squared is 100 squared, c squared is x squared. And there we go. 15 squared is 225 with two zeros, 22,500. 100 squared is 1 followed by 4 zeros, 10,000. Okay, 22,000 plus 10,000 is 32,500. And x must be then the square root of 32,500 feet, which is approximately, maybe equal, maybe exactly equal, but we'll find out here. Let's pull up Desmos. Desmos, not Des least. Okay. And graphing calculator. I feel like the Disney Clubhouse. Oh, Toodles! Oh, Desmos! Every time we need a calculator. Oh, Desmos! Okay. And so we're going to do square root, SQRT, and we're going to do 32,500. Okay. So 180 point, and if I go to the tenths place, 277, so the tenths place would be 3 because the 2 rounds up. 180.3 feet. Okay, always check, is that answer reasonable? 180.3, that's longer than 150, and we expect it to be longer. The hypotenuse is always the longest side, and it does seem to be a reasonable answer. Okay, so the distance between the helicopter and the observer on the ground is 180.3 feet. We might be asked another question: what is the angle of elevation? Let's call this y, or the angle of depression. They're the same thing really in this context because alternate interior angles are congruent. All right, so in that case, then we can use a trig function, right? So I know y is the reference angle right here is the reference angle. So if I go across the triangle, this is the opposite side, and this is the hypotenuse, and this is the adjacent side. Okay, and then I think, which trig function uses opposite and adjacent? OA. I think so, ka, toa. So, ka, toa. What has OA? Ooh, toa. So I know tangent is the correct equation. So tangent of the angle y equals opposite 100 over adjacent 150. Okay, and now we have tangent of an angle equals a ratio, right? 100 over 150. We could reduce that ratio. There's really not much point since we're going to be reaching for a calculator anyway. But this involves finding the angle, so we're going to use something called an inverse function. We're going to undo our anti-tangent, right? So we're going to say we're going to do the arctangent of 100 over 150. Okay? Now there's several ways to enter that. You can say arctan. Some calculators, the Microsoft Excel does this, does atan. And most calculators will do tan with a little -1. Okay? And Desmos will do both. It'll do arctan, it'll also do tan with a little -1. Okay? And basically the arctangent or inverse tangent, arctangent, gives you the angle that gives you that ratio. So the answer to an arctan or arcsine or arccosine is an angle. Again, as with all Desmos stuff, we got to click the wrench tool. We got to make sure we're in degree mode so that we're getting our answers in degrees. Okay, and we can just do this: arctan, A-R-C-T-A-N, parentheses 100 divided by 150, and we get 33.7. 33.7 degrees. Now, just to show you, it will also calculate using the little -1. Let me show you that here. So if I use the keyboard icon here and go to functions and go to trig functions and then inverse trig functions, there's tan little -1 and arctan. 100 divided by 150. Notice that the answer is the same. So Desmos recognizes arctan or tan little -1 as well as the same function. Okay, I prefer arctan because it's easy to type and I don't have to use the keyboard clicks there to get it. Now, as with all questions that we answer, we got to check, is this a reasonable answer? Is it reasonable to say this is 33.7 degrees? And I think so. 45 degrees would be a perfect diagonal. It seems to be a little flatter than a perfect diagonal. Okay? And that goes for the angle of elevation as well as the angle of depression. They are equivalent. All right, so hopefully that helps.